exists. It's real. It's not just stuff on the television and on BBC Click and all that sort of thing. This is the version 2 Zipline aircraft, and I'm with now. Who are you, sir? I've forgotten your name already.
Dan Zerwanka.
Dan and
Nixon Dangalasi.
Nick. So this is version 2, I think, isn't it?
That's correct. Yeah. This is latest and greatest Zip, as we call them. It has a lot of advances that the previous version, from the previous version, that you might not see. I mean, you can obviously tell it's a different shape. For example, the body can provide up to 20% of the lift on takeoff because it's shaped like a foil. It's also, made out of a specific type of foam that gives it a nice aerodynamic shape with low weight, but also cushions on impact. We fly cold chain products. So
Oh, you said on impact. How many impacts have you had?
Well, knock on wood, none that I know of.
Okay, well that's cool.
Yeah. But safety is really important with drones, so we designed for safety.
And the whole design is more modular, so you have the wing separated, you have the battery, and you have the body. So in case a wing has a problem, then not the whole vehicle. The whole vehicle is not going to be down. So you're going to repair the wing while the vehicle is keep on moving forward. So the idea is that to have the vehicle use more time and reducing the downtime.
But when you swap parts out, so that would mean then like the whole aircraft then hasn't been the whole aircraft the whole time. It might have been the right wing of one and the other one. How do you track then? This wing's done X hours, the tail's done Y hours. How do you track all that sort of thing?
So definitely we have a software which is integrated and which tells so we know this wing has flight this number of flights, this battery is flight this number of flights, and when we feel like this is the maximum amount of time that it has to fly before servicing, so we get that detail from.
And so have you got an idea of those service intervals then?
Say again?
Do you have an idea? Do you have a number for that service? Is it every 100 hours, every 1,000 hours, every 5 hours?
That it depends on different RLUs, depending on different parts that we change.
So just so you have the concept down, a line replaceable, you're going to call them LRUs, is a modular piece that we can take on and off. And we have high level and smaller level, right? So the 3 highest level of the aircraft are the wing, the fuselage, and the battery. And then, of course, each of those pieces has line replaceable units as well. So like the fuselage, these tails, they only have 4 screws on them, and they have a flexible cable in it with the servo gear on it. So if the tail breaks, you just slide it off and screw another one on. So that also is an LRU, right? The next level down.
I noticed there's sorry, I didn't mean to jump in here. There's quite a bit of 3D printing going down here.
Control surfaces are all 3D printed. Yeah.
And so can you manufacture those at your bases?
In fact, we do, yeah. So, and that's actually a great thing to point out. I don't know if I made the announcement in the speech earlier, but we produce all of these in our South San Francisco facility. But we've been manufacturing batteries in Rwanda for most of the year.
Okay.
And starting next year, we're actually going to be manufacturing the entire Zip in Rwanda. So, it's
And so what sort of speed is it flying at then? If I've asked you things you don't want to tell me, just tell me, don't go away. But what sort of speed do you fly at?
So we fly 30 meters per second. That is like the cruising, but sometimes you can get a little bit higher than that.
So about 60 knots, and then what sort of height are you cruising at?
So we're cruising something like 150 meters.
150 meters. Does the thing terrain follow, or just get up and get over whatever?
We try to reduce terrain following because ascending and descending uses up a lot of extra battery.
Yeah.
But the challenge, is that we fly below the 400-foot ceiling, and so we want to keep separation between manned air traffic and us. And so, for example, in Rwanda, it's quite difficult because it's a very hilly country, so we do a lot of terrain following. But we try to make our aircraft as efficient as possible. And I mean, I've seen this plane when we were prototyping it, and the motors went out, and it glided for, it must have been 2 miles before.
So would you change the track in order to be more to avoid an amount of a more circuitous track to avoid a great deal of terrain following? A few more.
So we actually have a GIS and mapping team that prepares 3-dimensional maps of all of our flight routes. And basically picks the optimal route to avoid any kind of obstacles that our customers request, and then also obviously optimizing our range.
All right, let's start at the nose. I should have done this at the beginning. So you know, that's where you have the blood samples. And for those people that don't know, you then you drop the blood down, not blood samples, but blood. Yeah.
Parachutes that we drop. And you know, it doesn't look like there's a lot of engineering here, but there's quite a lot of engineering that goes into manufacturing a wax paper parachute that can be accurate within 2 parking spaces from 30 meters up.
So that was going to be my next question. So 30 meters is the drop height.
So
do you slow down? Sorry, go on.
Yes, I was going to say it's actually 30 meters above whatever the tallest obstacle in the area is.
Right.
So
Okay.
it's a bit higher, but.
And then do you slow down before you do that, or are you just going through at the same speed?
We generally slow down, and depending on the drop position, we will use actually reverse thrust with our motors. So we cruise on one set of propellers, but if we need to use reverse thrust to slow down to get into a particular drop area, then we'll use both propellers to slow us down, drop it, and then accelerate.
And I guess you've been out there, you surveyed the drop zone, you have an idea of how you're going to do it,
Yep.
and then so. If you were to, so could you get called, because you're kind of in a scramble situation sometimes, aren't you? Blood's needed in X and Y. Could you go to somewhere you've never visited before, or is it always somewhere that you've surveyed?
So how our contracts work is, our customers ask us to serve certain facilities, and then
Okay.
we then survey those facilities, and the folks that work at the health centers will actually tell us where they want the package to drop, and we'll survey it very accurately so that we can hit that spot every time. What you're talking about is more like a dynamic drop situation, and that is certainly on our radar. And there are some use cases that is definitely a requirement for, but our customers right now are not requesting that. So.
Okay, well, it's a silly question from me. So there's the Peter. So let's go down the aircraft. So you've got your 2 engines there, and you're telling me that you don't actually use both of them.
No, so we actually cruise only on one. This one is purely for backup and or for reverse thrust.
Okay. So that's, I see, I automatically assumed it was for a loss of power asymmetric issues that you had that like that. So I was wrong.
It also can be a backup. So if the primary motor were to fail, then we can certainly just fly on that.
And you haven't, because you haven't got them out on each wing, you don't have asymmetric problems. Should there be your problem?
The other thing that you may notice that's different from our previous aircraft is before we had 2 propellers and they were right behind the trailing edge of the wings. And so, there's 2 different speeds of air coming over those wings, hitting those propellers, and so the propellers in the turbulent air make a really loud whine. And also, there's nothing blocking, so you hear it on the ground a lot more. With this new design, because the propellers are spinning in one airflow and it's smooth above the fuselage, it's first of all, it's quieter because it's not hitting turbulent air, but also the body itself tends to reflect the propeller noise north up, and people on the ground don't even hear the aircraft hardly, and you can barely hear it when it's over you.
Well, let's keep on moving down the tail. So you said, sorry, man. You said that this is very quickly interchangeable.
Nick,
So
why don't you tell them about that?
Okay, yeah.
So the LLUs, like the tail fins, they are very easy to be interchanged. They have been made. The engineers try to make them so that they can be swapped within 5 minutes. So that to reduce the downtime in case we have a down vehicle. So if I have to swap the tail fin, then should not take me more than 5 minutes.
So how's it work out at out at your sort of drone port? Are you the pilot in charge, and so you're in charge of not just the flight but replacing bits, or is the engineering team in charge of replacing the bits? How does that work?
So we have operators, flight operators, and we have technical leads in the group of flight operators. And these technical leads are responsible in doing the maintenance of the vehicle. And with the support of the engineering team, which is in California, and this team will always work in troubleshooting all the problems, and will help with the technical leads that we have in Rwanda, which are most of them, they are Rwandese.
So I'm the pilot operator. So when I go to work, I sign in, I sign out an aircraft, and and then I start using that, or does any operator grab something and go?
So how it works is that we have 3 or 4 operators in a shift, and this guy sign in, and then one person goes in a control tower. He is a controller, and he'll be monitoring every drone that is taking off, requesting clearance from the civil aviation, and also maintaining, monitoring it all the way as it goes, it drops, and as it transits back. And the other operators that are down, they are cooperating in assembling the zip, inspecting it before launch, launching it, recovering it after recovery, and inspect it after flight for any problems. So it is not like you are assigned to one zip, no, but we assemble together, and then we launch, and then we recover it, we inspect. So
is it one for one out, and that's it, and one back?
Yeah, maybe explain too about how LRUs are assigned to each other when an order comes in too.
Yeah. So what happens, as we told you, it's more of a modular. So we have a drone, which is a body seated somewhere. We have a set of wings seated somewhere, and we have a batteries charging somewhere. So when we receive an order, we take that order from the full ops, the half ops that are packing it, and then we load it in on the body. We put it on the launcher. Then one operator goes and grabs the wing, put it on. Then another operator at the same time goes and grab the battery. So we come and put it on. When it is done, then we do the walk around checklist, inspecting every part of the vehicle if it is good for flight. So we do one goes in the other way, one goes in the other way, then we swap at the tail. This goes and cross-check the other one to make sure that if you missed something, the other one can see it.
Oh, okay,
So
yeah.
Okay,
Yeah, that's a good idea.
Then after that, one person stands and launch the vehicle, while the other one confirms that the launching area is clear, if there is anything in the airspace and stuff like that. So we have we say 2 people doing one task and counter checking each other.
Now I see on the tail there's some QR codes. So if I scan these now, will I get some great video to watch or something like that?
Well,
We need. It's not powered yet, but basically these QR codes, what they do before flight, we have to make sure that all the control surface work. They are in a good shape. So what we do, we scan, and then the QR code will go up and down all the way.
So you have an app and you scan this, and then that forces a flight check routine.
Yes.
And then the app then, explain to me.
Specifically, what happens? We call them magic wands, but they're iPhones with a certain application that we use. And when you look at the QR codes, it looks like just a camera screen on your phone, but you'll see the QR code, and then you'll see in augmented reality a green cube over top of the QR code. And so that actually can measure all the movements and the deflection of the control surfaces. But the other important thing that it does is that cube can measure micro vibrations that the human eye can't see. And so that could generally predict failure of a part and allow us to pull that part before we put it into service.
So then you do that and go, oh, right, something's a bit wrong there, right? Just pull that tail off, get another tail, because everything else is loaded and ready to go.
Or would you basically, if something wrong with the vehicle, we'll immediately swap with another good vehicle, because
the entire vehicle. You take the vehicle, so you just
another one down.
so you just get another vehicle out and just. We'll worry about this one later.
Exactly.
And
well,
dual
someone else will be over there and just put it in,
And dual surfaces for redundancy. So is that why there's 2 surfaces here rather than just a single surface running up here?
Absolutely no. This is not for redundant. They both work on different issues, so it's not for redundant. You want to add something?
No. That was,
And then what's this for? What's this for here?
So this is how we recover the vehicle. So you see this tail hook?
Yes.
And we have a line on our recovery system, which is like a metal structure with two poles, and the line go through them. So when the vehicle is coming back home, and then this vehicle communicates with our ground equipment, and at accuracy of 2 centimeters, these 2 poles will snap up and then make sure that the line is caught on the tail hook, and that's how the vehicle is recovered.
So it's much like a fighter on a carrier.
Same.
So it snaps. So you say within 2 centimeters. So how far away is? And if you don't mind me asking, so what speed is it flying? Do you slow down for the landing, or do you?
Yes.
Yeah. Go ahead.
So we slow down for the landing a little bit so that we can get that 2 centimeter accuracy, and also to reduce the impact, because we are going to force
You're
land
gonna
to go very fast. It won't be.
That's amazing. I'm sure I've forgotten lots of things to ask you. And my dear viewers back at home, I'm sorry if I've done that. Send me in the comments, nag at me, and I'll try and catch the guys and work out what I should have asked them. But please, thank you very much. It's very interesting to see it in the flesh.
Yeah.
And
Thanks, everybody at SBS News.
cheers.